Well, hello and welcome. We are on skill lesson 7, finding, if my pen will work, finding a value of a function. Now, those that took Algebra 1, you should recognize that word pretty well, function. We use that word especially a lot in terms of transformations. And so this is a nice introduction in how to handle functions in reference to geometric transformations that we learned about in geometry. So this goes back a little bit to Algebra 1 here. So feel free to read through the text on this page for examples. Of course, the whole point of this video is that I can work through the practice with you. So we're going to just kind of scroll along past the function tables all the way to the practice. So let's take a look. The directions tell us find the value of the function for each input value. So what we're going to do is we're going to take the input value, which this reads f of x equals 12 minus 3x for x equals 10. So 10 is what we call our input value. We're going to plug it into this function here, and we're going to produce an output. Now, typically in algebra, what you do with an input and output is it creates a coordinate, and then you graph that coordinate, and it represents a graph of the function. So, but for the sake of this practice, we're just going to work on essentially evaluating the function given this input. So essentially what we're going to do is we're going to replace x with 10. So if x equals 10, then f of 10 is equal to 12 minus 3 times 10. So now what we're doing is we're performing order of operations, PEMDAS, of course. And so the first thing we're going to do is we're going to do the multiplication here between these two terms. So just get in the habit of bringing down f of 10 equals. So we're going to multiply a negative 3 times a positive 10, which is a negative 30. So bring down the 12 minus 30. And now simple subtraction, 12 take away 30. F of 10 is equal to negative 18. Pretty simple. Just plugging in an input, producing an output. So for those that are trying to follow, this is what's called the output value. Now let's take a look at number 2, slightly more complicated, but still the same process. We have this function here, k of x equals 1/2 times x squared minus 2, and our input is 10, x equals 10. So k of 10 is equal to 1/2 times 10 squared minus 2. Now, if you recall, and I'll even write PEMDAS up here just for a second, a lot of times students will misinterpret what the P stands for in terms of parentheses. So you might think you need to handle this parentheses somehow, but parentheses really means is there any work to literally be done inside the parentheses? And there is no work to be done with the number 10. It is just 10. So we move right on to our exponents, and that is this tiny little 2 here. So the first thing we're going to do is we're actually going to take 10 and square it. So k of 10 is equal to 1/2 10 squared, which is 100, minus 2. Then we move into multiplication, and we work from left to right, which is 1/2 of 100. So half of 100 is none other than 50. And then we move into addition or subtraction, and our output, k of 10, is equal to 48. So just little, essentially work on order of operations here, but in function notation. It sets us up really nicely for our transformation lessons. Sorry about that, moving right along. So same thing, we have our function g of x equals 3x plus 5, all divided by 7, and our input is negative 12. Notice how I read that, all divided by 7. There's a reason I said it that way. So let's plug in negative 12 for x and then do order of operations. Now, it is understood that fractions are considered division. However, when handling a fraction, we have to simplify the numerator first, which is the top of the fraction, before we approach any kind of division here. Or it's definitely more mindful to do it that way. It gets a little bit more tricky when we start trying to handle that division. So we're just going to go and simplify this top using order of operations. So I'm going to do multiplication first. So 3 times negative 12 is negative 36. Bring down the plus 5 and bring down the positive 7. Now let's combine negative 36 plus 5. We get, when you add a negative and a positive, you subtract them, then keep the larger sign. So negative 31 over 7. Now you could divide here. It doesn't look like 7 will divide into 31 evenly. As you know, I prefer improper fractions over decimals, even over mixed numbers. So we're just going to leave that as g of negative 12 equals negative 31 over 7. Now let's take a look at number 4. So we have our function here, f of t equals 5 times 2 minus t squared for t equals 0. So our input is 0. So f of 0 equals 5 times 2 minus t squared. Sorry about that. Go and replace t with 0. Not sure why I didn't do that. Now, this is where the P in PEMDAS really comes into play. So the first thing we're going to do is we're going to look inside these parentheses and see, is there any work to be done? And there absolutely is work to be done. First thing I need to do is, now once you're inside the parentheses, you need to really handle PEMDAS again. Go through exponents, multiplication, division, addition, subtraction. So before I subtract, I have to square 0. So I'll bring down the 5. And when I square 0, I still will get 0. 0 squared is 0 times 0, which is 0. Now I'm going to go and combine these two terms, still working inside the parentheses. And 2 take away 0 is 2. And last but not least, now we've moved on. All this parentheses really implies is multiplication. I don't know why I wrote 10, f of 10. Some of you are probably freaking out as you're watching this. Why did he write 10? It's a simple mistake. A lot of these inputs have been 10. And if you can't tell, the answer is, the output is going to be 10. So f of 0 is equal to 10. Now we transition. If you notice the directions change just a little bit, we're going to now find the input value of the function for each output value. So essentially working backwards here. So now they're telling us not that x equals so-and-so. They're saying if f of x equals this value, so that's our output value given this function. So using this function, we're going to replace f of x with 7. So 7 will equal negative 2/3 x plus 3. Now notice what we're solving for. We're actually solving for x, which in this case would have been our input value. So we're literally doing the exact opposite. We're still going to perform our order of operations in the same way. So we need to solve for x. So here's my advice. If you don't like fractions, let's go ahead and multiply everything to get rid of this fraction. That is definitely a possibility there. I prefer, though, I will keep this x term on this side by itself right now. I like to get my x terms by themselves first. So I'm going to move this positive 3 over here by subtracting 3. This is by no means the only way to do this, but I think it's a great method here. So now we just got the x term by itself on the right, negative 2/3 x. So now let's consider how to get rid of this negative 2/3 x. So I'm going to do the work over here to show you negative 2/3 x is really negative 2/3 times x over 1. So the way to view it is we're really multiplying x times negative 2 and then trying to divide it by 3. So we're going to undo that in reverse order. So I'm going to go and multiply everything by 3 to cancel out what's considered this division of 3 on the right side. And 4 times 3 will be 12, equal to. So all we're left with is that negative 2 times x. Now to undo that negative 2 multiplying by x, we're going to divide by negative 2. And whatever you do to one side, just like we did with the multiplication of 3, we have to do to the other side. So negative 2 divided by negative 2 becomes 1. I know we use the term cancel. I really hate that because we use the term cancel in other areas and it can confuse students. So it becomes 1 or 1x, and we don't have to write a 1 in front of x. And 12 divided by negative 2 is negative 6. So x equals negative 6. So here's something pretty great that you can do. This is our input value. So I should be able to plug in x equals negative 6 right here and perform order of operations, and I should get my output of 7 if f of negative 6 is in fact 7. So it's a great way to go back and check your work once you find the input. Now let's take a look at number 6. I'm going to clean this work up over here. So our output for this function is negative 2, and our function is f of t equals 16 minus 2t squared. So if f of t equals negative 2, I'm going to replace f of t with negative 2 and set it equal to the function 16 minus t squared, or 2t squared, excuse me. Always check to make sure you copied it over correctly. So just like on this last one, I like to get my x term isolated first. In this case, the t term isolated. So I'm actually going to get this entire term, negative 2t squared, by itself first by getting rid of this 16. Now this is technically a positive 16, so to move it across the equal sign, I have to subtract it. It will cancel there, and cancel on this term means to become the number 0. That's why I really hate the term cancel, because here cancel means become 0. Here it means becomes 1. Negative 2 take away 16 is negative 18, equal to negative 2 times t squared. Now to further isolate x, or t in this case, which is really what we're doing, we're trying to solve for t, is I'm going to get rid of this negative 2 that's trying to multiply by that t squared term. So since negative 2 is multiplying by t squared, I will divide by negative 2 in the same way we did over here. And when I divide negative 18 by negative 2, I get none other than positive 9 equal to t squared. Now here's something that many of you might not have learned, and I probably overlooked if I checked your work already. But there's something interesting about when we're trying to solve for t at this point. To undo t squared, because our job is to just simply find t, when we take the square root of both sides, truthfully, t can actually be plus or minus the square root of 9, which a positive or a negative square root of 9, which is 3. Reason being is a positive 3 squared is 9, and a negative 3 squared is also 9. So truth be told, on item 6, t can equal 3 or t can equal negative 3. If you plug in either of these input values to this function, you'll get that same output value. So something pretty interesting happening there. Let's move on to number 7. Same thing, we're given the output, g of x equals 4, and the function g of x equals 5x minus 3 over 8. So think about it, we're really trying to say if g of x equals this and g of x equals this, well, this really should equal that. So that's what we're doing here. So 4 will equal 5x minus 3 over 8. Now, some of you approach this very differently. And there's no really one way to do this. But since this is 5x minus 3 all divided by 8, and my goal is to solve for x, the first thing I'm going to do is get rid of this division of 8 by multiplying both sides by 8. Now we'll cancel this division on the right, aka becoming the number 1, and multiplying by 1 is pointless essentially because it does not change the value. Multiplying on the left side, 8 times 4, we will get 32, equal to 5x minus 3. Now again, I like to get my x term isolated first, or by itself is what isolated means. So I'm going to add this 3 across the equal sign so that it cancels and becomes the number 0. I will get 35 on the left equal to 5x. And last but not least, 5 times what number is 35? Well, if you don't know it, you can divide both sides by 5 to cancel out that 5. And of course, canceling here becomes the number 1, and so x equals 7. So again, feel free to go back and plug in this 7 for x, and you'll see that this function yields the output of positive 4. Now the last one of this kind, number 8, our output is 0, and our function is 6 times t squared. So you might already be imagining what t is supposed to be, but we'll go and solve this one out. So 0 equals 6 times t squared. I'm just going to go and approach it the same way as if it wasn't 0. So I'm going to get this t squared term isolated first by dividing both sides by 6. So it cancels here because 6 divided by 6 becomes the number 1. So it's 1t squared, or simply t squared. And 0 divided by 6, well, is 0, right? And so just like we did, I believe it's on item 6, we're going to take the square root of both sides. That's how we undo a square, is we take the square root. So the square root of t squared is t, and the square root of 0 is 0. Well, you might be asking yourself, well, shouldn't it be plus or minus 0 like you said on item 6, I believe? Well, actually 0 is nothing. It doesn't really have a sign. It's neither positive nor negative because it's nothing. So t is simply 0. Now the last two on here, they give us a function and a function table of input values, and our job is to find output values. So it's just a different format of what we did for items 1 through 4, I believe. So we're going to take each of these inputs. Notice they're listed as x equals -5, -1, 0, 6, and 8, and produce an output using this function here. So we'll show the work for that. So f of -5, we'll start with this first input. -5 is equal to 17 minus 3x. I don't know why I wrote x, might as well go and replace it with -5. So we'll just be in the habit of bringing down f of -5. So we're going to do multiplication first. -3 times -5. So we'll get 17 plus 15. And then we'll simply do addition, and f of -5 will be 32. So we'll put that here in the table. So if x is -5, f of x is 32. We'll do this second input the same way. F of -1 is equal to 17 minus 3 times -1. And just following suit on what we did on the first function, f of -1, we're going to multiply these two terms first. -3 times a -1 is a +3. So it's 17 plus 3. So f of -1 will be none other than 20. Simply enough, right? Just using the same function with different input values. Now let's use 0 here. So f of 0 is equal to 17 minus 3 times 0. We're going to do the multiplication first. Order of operations. -3 times 0 is none other than 0. And this is where it really doesn't matter if I wrote plus 0 or minus 0, because 17 plus or minus 0 is still 17. So f of 0 will give us 17 as an output. Now let's do an input of 6. So f of 6 is equal to 17 minus 3 times, and again, we're just simply, if you've lost track, we're just replacing x with 6. Order of operations, we'll multiply first. So -3 times a +6 is -18. And 17 take away a 18 is none other than -1. So f of 6 is -1. Last and certainly not least, on this function table is f of 8. I'm going to eventually have to erase this because we'll have to do 10 as well. So 17 minus 3 times 8. Hopefully you're getting a good routine here. -3 times 8 is none other than -24. And now we'll subtract 17 minus 24. So 17 take away 24 is none other than -7. So we have just used these 5 input values for this function, 17 minus 3x, and we got 32, 20, 17, -1, and -7. So you could actually graph these if you wanted to, just to understand what's really at play here. This would be your x and this would be your y. So this would be one coordinate, -5, 32. And then what you're really doing is you're graphing a linear equation. They all represent something different in algebra here, but they're all remotely the same math. Last and certainly not least, number 10, as I clear everything off the screen. So, same process. We have our input values here. We have our function. So let's get to work. We'll start with -6 as an input. So g of -6 is equal to 1/3 times -6 squared plus 2. Bring down g of -6. Now, order of operations tells us to do parentheses first, but parentheses here is just the number -6. There's nothing to be done inside of those parentheses. In fact, I was the one that drew those parentheses just because I was inputting a -6. So we're going to go and do exponents first, which will take -6 squared. So we'll go and bring down the 1/3. A -6 squared is a -6 times a -6, which is a positive 36. And of course, bring down the plus 2. Now we will work with multiplication next, left to right. So 1/3 of 36 is the same thing as 36 divided by 3. So 1/3 of 36, I believe, is 12. And 12 plus 2, our final operation, is 14. So if t is -6, then g of -6 is 14. Nicely done. Now let's move on to our next input of 0. So g of 0 is equal to 1/3 times 0 squared plus 2. So we'll square our input first. 0 squared is none other than 0. And if you're thinking, well, 1/3 of 0, well, none other than 0, right? So when we plug in 0 here and we're squaring 0 and multiplying it by 1/3, this term eventually becomes the number 0. Because 0 times any number, including itself, is 0. So g of 0 will equal, well, what's 0 plus 2? None other than 2. So this entire term here, when we plugged in 0 for t, became 0. So we were left with positive 2. Moving right along, probably should do a little erasing here. I'll just work on this side actually. So 15. So g of 15 is equal to 1/3 times 15 squared plus 2. Don't forget, we need to square that 15 first. We will get 225, I believe. Next, we need to take 1/3 of 225, or 225 divided by 3. If you're familiar with that concept. 1/3 of 225 is 75. Last but not least, g of 15, we'll add 75 plus 2 and get none other than 77. So our number is increasing rather dramatically here. Makes sense because we are dealing with an exponent. So it's exponentially growing, if you will. And last but not least, 21. So g of 21 is equal to 1/3 21 squared plus 2. So we're going to take 21 and square it first, which will give us 441. See, exponentially larger, right? That's not 21 times 2, that's 21 times itself, which is 441. And then we need to take 441 and take 1/3 of it. 1/3 of 441 is none other than 147. And then last but not least, we need to add 2. So g of 21 is 149. So that is our final output given this table and this function. And that is actually the end of our skill lesson 11. Thank you for watching. Hope it helped.